Here we go. So now, welcome everybody watching on YouTube. And so now that we've got the introductions out of the way, so welcome to the Math and Statistics major at San Jose State. I'm Dr. Shu. I'm one of the people you see around the department, and there are all sorts of other folks but actually, and so normally many of them would be here, but this is just an amazingly busy and chaotic semester. And so a lot of them people who normally would be here couldn't make it. But anyway, here we are, and it's a pleasure to see you all, and to see everyone on YouTube. And I guess for the people on YouTube, I'm going to say something. I'm just going to go ahead and get to the most important slide right away. So if you only watch like 30 seconds of this is the money 30 seconds. So for anybody majoring in math or statistics at San Jose State here, I mean, this is actually true probably of any math or statistics major anywhere. But let me just skip right ahead. There's all kinds of stuff here we're going to talk about, but here is the big one. So listen, so if you get anything out of this presentation, the thing to remember is not to take too many, and this is a very strange piece of advice because it runs counter to everything you've ever heard about making progress in college or majoring in mathematics. But don't take more than 2 or 3 math stats classes a semester. That is like my iron. That's like my one iron as an advisor. I've been an advisor for quite some time now. That's my one iron-bound rule. Don't take more than 2 or 3 math stats classes each semester, because it often ends up, when people do that, when they take 4 math classes, or God help us, even 5, that often ends up delaying your graduation. So anyway, so I just want to get to the money slide there for those of you watching on YouTube. And so okay, I hope you pay attention to the rest of this, but that was really probably the most important slide of this whole thing. Okay, so anyway, let me begin the presentation per se. All right, so to go back to the beginning. So you've heard about teaching math. So and actually, I just saw. Let me see if I can take a survey here. So if everybody can. Actually, yeah. Just let's do this on the chat. So if everybody can open up the chat window. How many people here? Can you just say hi or yay in the chat window? How many of y'all are majoring in teaching or plan to be teachers? A couple people. So that's 1. Yeah, we had a couple people here. So and there's of our hardy few here for this live. There's a couple folks. So and a lot of you. So another person who's here today actually was wondering what there is in terms of what kind of careers are available in mathematics if you're not a teacher. But for those of you teachers, you've heard how this works. You were aware, I'm sure, that with a math degree you can become a teacher. So let me give you some details on that. So if you want to teach math, then what you need is a bachelor's degree in math plus some additional training, which is called a single subject credential, and that qualifies you to teach high school math. And as of just a couple of years ago, this is the first time that program ran. A new integrated program does it all in 4 years. So yay! Everybody here in the integrated program. It's an awesome program, and we're sort of just seeing we're starting to see its new graduates right now, and now I guess really next year especially. So this is a great program, and congratulations and welcome to it. All right, so that's what you have to do to teach high school math. You need a bachelor's degree in math and a single subject credential. Questions? Or is that? How do you know if you're in the integrated program? I think you would know. Actually, if Mindy, you want to say how you know you're in the integrated program? Or well, I think you would know. I mean, you would if you want to say in the chat how you sort of got into the integrated program. I think the answer is that you would know. I believe it's a separate application progress, but I think you can actually join it still. So if you want to get it all done faster, and if you have your sights set for sure on teaching, you want to all get it done faster. So talk to. So if you have any questions about, I guess I should say, if you have any questions in general about teaching, what you should do is you should talk to, hang on. Let me put in something over here for questions about teaching high school math or secondary education is a sort of more general term. Talk, email, Dr. Roddick, Cheryl.Roddick at sjsu.edu. And right. So let's see. So that's how you end up teaching high school. That's what you need to qualify to be a high school teacher. If you get a master's degree, which is 2 more years after a bachelor's degree, that generally qualifies you to teach at a community college or work as a lecturer in a 4-year college or university. So somebody just asked on the chat, does every college professor have a doctorate? So probably if you take that question literally, the answer is yes, because the title of professor, which is a particular title, not all instructors are professors. People with the title of professor generally have doctorate. Almost all have doctorates, but there are lots of folks who teach at San Jose State who have a different title of lecturer, and those folks generally have master's degrees. So whoever the person who asked me that on the chat, did I answer your question? I hope. Yeah. Okay. Great. Right, and feel free to ask me questions on. Those of you who are here live, please feel free to ask me questions privately on the chat or publicly, whichever you like. Anyway, so yeah, so bachelor's degree plus a credential gets you to teach high school. A master's degree gets you to teach a community college or work as a lecturer at someplace like San Jose State. And a doctoral degree, which is sort of 5 to 7 extra years after your bachelor's degree, that qualifies you to be a professor at a 4-year college or university. And indeed, most of the folks who have the title of professor, I think in our department, everybody. It's not true in every department, but in San Jose State Math Stats, everybody here who has the title of professor does have a doctoral degree. So here we are. So anyway, so the point is, I guess, my point was that this is something you've probably heard about. You're probably aware that if you get a math degree, you can go teach. But the thing that a lot of people are not aware of. In fact, one of our attendees today was saying that they had not that they were interested in what you could do with math besides teaching. Well, there are lots of things that non-teaching things you can do in math, and so here are some of them. So and these are actual concrete examples of things that people are doing sort of after graduating from San Jose State recently, and recently would say within the last 5 to 10 years. So people with bachelor's degrees have gotten jobs like being an investment advisor, and these are actually just all students that I've had personally. One of our recent BA bachelor's graduates, BA or BS, is working as a quality assurance engineer. So a software tester, and at a company at a sort of cloud storage service called, I believe they do cloud storage, called Cohesity. And it's funny, that's actually, for those of you who are in the BA math and sort of think about fancy classes like abstract algebra, his job is actually applied abstract algebra, which I thought was really interesting. We have any number of programmers with bachelor's degrees. I mean, these are referred to as specific. A specific example here at working at Sun Microsystems / Oracle. There are people going to business, certainly, and one of our sort of real successful alums who's gone into business is working as a senior analyst at Salesforce. They have the big tower in San Francisco, that place. I'm not sure if I don't think he's actually working in San Francisco, but there is the big tower in San Francisco. And and one of our super successful alums who has a degree in applied math. So you probably have not heard of this company, Zoox. I'm not entirely sure what I can say they do, but this is because it's a company that our alum started, or at least was sort of in on the ground floor of. I can't remember if he actually started, or maybe he was like employee number 1 or something. But so there are people that, and I think I can say that their business has something to do with self-driving cars. So which is a big booming area of interest these days. So people with bachelor's degrees go off and do lots of very interesting things. Master's graduates also do very interesting things, and master's graduates are especially sort of so these. I think what happens with bachelor's graduates is often if you have that master's degree plus a certain amount of entrepreneurial drive, so you can be very successful. I mean, if you have a master's degree, it's sort of more obvious that you have a. I mean, it's another 2 years of schooling, and so it's sort of more obvious that you have a kind of professional certification. And so these folks often all really kind of go off and often do some kind of engineering, essentially. So there's people working at Lockheed Martin. There are people working. We've had several master's alums working in aviation analysis. Somehow this ATAC corporation, which works with the FAA, is sort of we have some connection there. Actually, one of our master's graduates did something really cool. I thought this was a really cool job. So if you ever watch any kind of TV sports, if you ever seen like baseball games where they paint the strike zone somehow with a computer in the air next to the batter, or if you watch the Olympics a couple years back, where there are people swimming in lanes and they somehow magically paint a computer flag in the swimming lane, which is not actually there. It's just an illusion. It's just an illusion of computer graphics. That's all done by this company called Sports Vision, and I thought that was a really cool job. It turns out that all those problems of like painting the strike zone or painting painting the lane of an Olympic swimmer, that's all done. That's all I think a very large linear algebra problem actually. And of course, you may have heard this little old company around here called Google. Rhymes with schmoogle. And yes, algorithm-based computing, so ADS. And so PhDs generally often do go teach at universities and four-year colleges. But PhDs are also happen to be in demand in the fields of cryptography and operations research, so optimization, among other highly technical fields. Actually, this is not somebody from here, but actually, I just want to mention, like, if you were wondering what operations research is, so here's an example of an operations research problem. Suppose you have a bunch of people working in a lab, and they all have to do various things in various places in the lab, but you don't want to have any two of them in the same room for over an hour. So this is, as you can see, during quarantine, this is a very, very relevant problem. And actually, a former student of mine from another college, she's actually now working at Lawrence Livermore National Labs. I mean, her normal sort of job is sort of optimizing things having to do with like nuclear weapons. But right now she's actually optimizing work times. So sort of setting up the work schedule, getting enough people in the office with the right expertise for a sufficient amount of time, and yet still, but sort of minimizing the amount of time that two people are spending in the same room, breathing the same air, which, as you can imagine, it's very bad. It's not a good idea to have these days, to have two people in the same room breathing the same air for a long period of time. So there's all kinds of stuff, and that's a math problem, right? The problem of trying to figure out, actually the problem that we've had in the College of Science, where not so much in mathematics, but where there's lots of people who have to come in for labs, and they all have to sort of monitor. They have to make sure their worms stay alive, and that their lasers are well maintained. The problem of getting people in for a sufficient amount of time that they can keep their worms alive and their lasers maintained, but also spend as little time as possible breathing each other's air, that's a math problem. So, I guess I should say this year, an extremely relevant field to be in is epidemiology. If you study if you happen to model the spread of disease, you're in high demand right now. So there's lots of stuff that you can do with a math degree. I guess I would be remiss to talk about marketability in the mathematical sciences without mentioning. Oh yes, oh gosh, this is actually this particular entry here I actually have from previous years, but this year happens to be much more interesting. This is one of these. I think that there's this. It's one of these things that I've always wanted people to understand exponential growth a little bit better. But unfortunately, people are finding out exponential growth the hard way right now with COVID-19. Anyway, but yeah, so you know, among the hot fields in mathematical sciences, I think this is from a few years back, but it's still true. So statistics is very hot. So any company that deals with data needs statisticians. Actuaries, there's a profession called the actuarial sciences. They use statistics to help determine pricing for insurance companies. So a typical problem that an actuary would do is that looking at, I'll use me as an example. Looking at me at my age, I'm 51. You look at my age, you look at where I live, you look at my lifestyle habits, you look at the kind of car I drive, and the insurance company is going to want to figure out, like, how long is this guy likely to live, and sort of based on how long their guess as to how long I'm going to live on average, that's how they price my life insurance. So that's the classic sort of problem in an actuary, and more generally, it's sort of the I guess we were just talking about operations research. A slide or two back, operations research is the science of better. The actuarial sciences is the science of risk. How risky is it to insure this person? Right. So those are, anyway, so that's just a couple examples of very concrete applications of statistics. People who study bioinformatics use statistics and discrete mathematics and apply that to molecular biology. And epidemiologists, well, I think, you know, it's funny. This slide last year seemed kind of abstract, but this year, I think we all know what an epidemiologist does. An epidemiologist studies the spread of disease, and they're very important right now. And in general, and this is also probably really relevant right now. Data mining. In data mining, or in big data, or in machine learning, these are all kinds of things used to describe the same line of work in many ways. You look at these modern computerized life, and the internet produces these giant data sets. And so what you do in data mining is you figure out some clever way, usually through mathematics, to study that data set and get sort of interesting information out of it. Say, I don't know, it would be really interesting to look at to be able to take data from, say, Google searches and figure out, where's the next big COVID-19 hotspot going to be. So if you can do that, that sounds like pretty valuable, right? So yeah, I mean, it's a weird time for everybody right now, but it's an especially weird time for mathematics, because there are all these things in mathematics that are suddenly very relevant. We all kind of wish we're not so relevant, but there it is. At least we can provide some kind of service. Okay, so are there any before we go on and talk about the degree itself? Are there any questions about what you can do with a math degree, or a degree in the mathematical sciences, in mathematics or statistics, and either in terms of teaching or in terms of careers in the real world? So any questions so far? And go ahead and type them on the chat if you have questions so far. Oh, is there a bio? Yes. So the question was, is there a biostatistics program at San Jose State? I think it's not called a biostatistics program at San Jose State, but if you're in the statistics program at either even at the undergraduate or the master's degree level, yes. I mean, we have a couple, two of our statistics faculty. I think at least two that I can think of, and then probably everybody is interested in does biostats in some level. But yeah, we do happen to have two specialists in statistics related to biostatistics, and so you can certainly study biostatistics here, even if I think we wouldn't call it that necessarily. One thing, I guess, if you're talking about special programs, this is data mining. This is a new just beginning MS program that we have now in data science, and therefore also data mining. So if you stick around and get into grad school, you can learn data mining right here and we have several experts in that area as well. So did that answer your question, person in the chat? Oh yeah, is there a minor? Let's see how many people. I've got a few more folks here right now. Is there a minor So the question is there, I'll say what the question literally asks, is there any minor, for example, bio or CS, for applied math major students? The person on the chat is asking this. Are you asking, is it possible? It's certainly, I guess let me give you two answers. It is certainly possible to minor in bio or CS for applied math majors. In fact, part of our applied math program is that there are these sort of the support courses, upper division support courses that you're supposed to take in some other subject, because part of the design of our applied math program is that you're supposed to learn a bunch of math. That's the applied math part, but then you're also supposed to be good at something else. And the idea is that whatever that something else is, let's say biology, is that whatever math that you learned in the math program, you would then go and apply it to biology. And if you're going to apply math to biology, you should go. You do need to learn some higher level biology. So it's not required to have a minor if you're in the applied math per se, but you do, and it is part of the design of our applied math major that you should learn a lot about some other subject, which I should say is, for most people, it's going to be taking more CS classes, but it could be biology, it could be economics. What else have I heard? I mean, it could be physics. There are lots of things that it could be. So so the person asking about minors, yeah, okay, we answered your question. Great. Any other questions? Will a math degree help obtain a front office job in sports companies? Maybe. Yeah, I think so. I mean, there aren't a whole lot of those jobs. I got to be honest, but yeah, I mean, certainly so one of the things. So yeah, we have a career day every spring, and the thing that I always say at that career day is that kind of the good thing and the bad thing about having a degree in the mathematical sciences is that you can do anything almost. I mean, and then the good thing, but also the downside is that you have sort of too many choices. What I often tell people, I mean, if you want to go, if you want to go teach, like, I pretty much knew I wanted to go teach, and so that was an easy choice for me. But if you're sort of not sure what you want to do,
up your ID. So that what we can.
Hi, who's there?
If they are new up in news, send ID. So that's the.
I think that person is. I'm going to mute that person, whoever the sound is coming from. I think. Yeah, let me go. I think that person is not intending to broadcast there. So somebody was asking about, will a math degree help obtain a front office job in sports companies? Well, my general advice to people is that if you have a strong interest in X and you're studying, and where X is something else, like I'll give a concrete example. So one of our alums from a few years back was really interested in environmental things, and so what happened, and the way he turned that into a career is that he ended up getting a job, sort of working as a manager, as sort of a supply manager at the Environmental Protection Agency. And so there he was able to use the sort of analytical skills and critical and sort of logical thinking and critical thinking to sort of make sure that that the EPA had enough computers and stuff to do their job. And so there he was able to combine both his interest in protecting the environment and also his skills in math. And so if you're really interested in sports and you get a math degree, yes, so your interest in sports and your strong critical thinking skills and analytical skills and a strong interest in sports, yes, you could be working for the A's and be the next Billy Beane, I guess, if that's what you're thinking. Yeah, Billy Beane's the guy in Moneyball. If for those of you who don't know who Billy Beane is, go look it up. You're on YouTube. Go search it on YouTube. Billy Beane. It's the movie with Brad Pitt in it. Anyway, so person who asked about a front office job in sports companies. Did that I kind of answer your question? I mean, I don't really know because I've never worked for a sports company, but a math degree and a strong interest in something and a sufficient amount of like entrepreneurial drive, basically, will get you pretty far. Oh, right. So somebody's asking about the applied math concentration econ actuarial science program. So that program is actually, I did manage to cut it out of this presentation, but I didn't actually say that. We're not accepting. We decided that the people, if you want to study math and economics or become an actuary, so if you want to be an actuary, we now recommend that you should major oops, they should major in statistics. And so if you're interested in doing sort of economics / actuarial science, that is basically having a business degree, the sort of mathematical version of a business degree, you should major in statistics, and that will sort of get you wherever the previous degree was going to get you, but maybe even better. So yeah, so that program is now sort of defunct. We just couldn't find anybody to run it because we don't have any actuaries. We don't have any actuaries sort of working on hand and in the faculty. And so what we're doing instead is we're telling people to go major in statistics to achieve really much the same goal. And actually, if you want to be an actuary, for example, so if you want to do this for a living, one of the big things you have to do is that you have to pass these exams. And besides a certain number of things in business, the hardest exams are all about probability and statistics. And so really, so yeah, if you want a sort of a business degree even a business related degree in mathematics, you should major in statistics. So did I answer your question there? Person who asked about econ and actuarial sciences. Okay, good. Any other questions about careers before we talk about the degree program itself? Great. These are great questions, by the way. Oh, and I see a few people are coming in a little bit late here. That's fine. By the way, but if you want to catch up on this presentation, this is all going to go on YouTube. The address will be mailed out. Will be emailed out with to the same list that this went to. So and if you miss anything, you don't need to take notes. These notes and the video of the presentation will all be shared via email. So just sit back and pay attention, I guess. You don't have to like write anything down. Okay, so I want to talk about the program itself. So that is one of the main things, purposes of this introduction. So the basic idea is that there are basically two kinds of bachelor's degrees in mathematics and statistics at San Jose State. There's the BA and the BS. There's a BA and basically what you might call pure math, and the BS degree in applied math. And so, what happens if you're interested in secondary teaching, if you're interested in teaching high school, basically, then what you end up getting, besides the credential, the teaching credential could either be happening now, if you're in the integrated program, or later, if you're in sort of the traditional longer program. That's just something separate. I mean, so the actual math that you study is the same as is pure math. It's proving stuff, basically. It's proofs, and so we'll get back to that. But so yeah, so this is kind of a traditional mathematics major in many ways. The other basic kind of bachelor degree is the BS in applied math, and so the BS in applied math. Oops, I knew I sort of. So you see there's like a hole here where the econ actuarial sciences thing used to be, and now I forgot to plug up one part of the hole. So there are two choices of concentration, but it's really kind of three sub flavors of applied math. So there are two concentrations. There's the concentration in applied and computational math, and the concentration in statistics. And then what happens is that, the concentration in applied and computational math really breaks down pretty drastically after a while into two tracks. There's sort of two different ways to do this. There's applied math, the sort of classical math. You're basically solving the kind of math problems that show up in physics and engineering. And there's discrete math, where you're doing applied discrete math. It's where you're basically solving the kinds of math problems that show up in computer science. So things like networks. Yeah, so the first is kind of like differential equations. Life is a differential equation, like F equals ma from physics. Well, that's a differential equation. That's the sort of thing that you solve. Or in discrete math, well, what do I mean by networks? Well, the internet is a graph, right? It's a bunch of dots strung together with connections. And so so Google, the company Google, is actually founded on by solving a linear algebra problem on that particular graph. So, this is all very relevant stuff. And then of course there's a concentration, and then there's a separate concentration in statistics, which I just mentioned is extremely marketable these days. Right. So again, if you're interested in business and economics or being an actuary, instead of going to the econ actuarial science concentration, which doesn't exist anymore, you should now go into. If you're interested in business, go major in stats. All right. So does that make sense? The types of bachelor's degrees that we have. If you're interested in data science and machine learning, oh gosh, which track would you recommend? Which track you should follow? Should you follow? Apply. You could make both work. Yeah. So so I'll be honest. I'm a pure mathematician. I've never had like a real job in my life. All I've done is this math thing. Which is great. But so I have only kind of a nodding acquaintance with the real world. So I tend to give the following piece of advice, which your parents might be appalled by, which is you should do the thing you find to be more fun. And you can make either. So the question was, if I'm interested in data science and machine learning, which track should I take? Should I take the applied math track? Right. If I'm interested in data science and machine learning, should I go here, the applied math track, or should I go here, the discrete math track? And my answer is you should do whichever one you find to be more fun, because this is like something your parents won't appreciate me saying, but really do the thing that you enjoy, especially if it's something that you really like or even love, do that. And then your career will sort of work itself out. I know that's like not very parental advice, but it's really true. Follow what you like. That's right. Okay, anyway, so I think I've said that like 3 times now. So, all right, any other questions about the sort of flavors of math stats degrees? Okay, I want to make sure to finish in time here. All right, so now that we've sort of established the kinds of math majors that we have, I want to talk about sort of the sequence of courses to take, and I want to also what I really want to talk about is why it sort of takes so long, because at least I think this happens less now that we have very assertive advising requirements, as you may have already discovered. There's one more job question. So without getting a master's degree, can we get a job easily? Well, it won't be as easy as when you have a master's degree, but you can get a job for sure. And it sort of depends on again, probably I would say like how interested you are in some particular thing, and how dedicated you are in pursuing that interest. So I think the math degree, while it sort of doesn't obviously funnel you in one particular direction, it will unlock the doors that you need to unlock as long as you're really interested in something. So I'd say, I mean, sort of the more degrees you have, like if you get a master's degree, then you're sort of that sort of more funnels you towards, it pushes you towards something. And so maybe if you're sort of not sure what to do, then you can always go to more school and go in that direction. But I guess it's sort of say the more school you have, the less you have to have your own sort of vision as to what you want to do for a living. But on the other hand, the more personal vision you have as to what you want to do for a living, the less school you have to take. So which field does it allow you? Well, I think the most common thing is some form of engineer. I think the person asking this question maybe missed the beginning, but yeah. So here's a pretty good list of what people are doing. So this is what are people doing? Business, engineer, business, engineering. So it's generally people do some form of engineering. Even your title is generally like some kind of engineer, even though you're really sort of secretly doing math. But it's usually either engineering or business. Did I answer your question? And yeah, bachelors can also, that's right. And these jobs that I list here, this person working in investments, working as a QA engineer, working as programmers, working as a senior analyst at Salesforce, well, I guess this person now has an MBA, so maybe this is a little bit misleading. But she actually got a bunch of jobs in business with just a bachelor's degree. And this person here this alum here who had his own startup, he just had a bachelor's degree. So yes, if you have a bachelor's degree and you have you need a sort of a certain amount of strong interest in what you're doing and entrepreneurial zeal. But yes, if you have those things, then yes, you can get a job. That's probably true of anything, really. That's probably also true even if you have a master's degree. It's as much as your strong interest in something and your sort of entrepreneurial spirit that gets you a job as much as anything else. Yeah, did I mention do what you love? And it's terrible advice, but it's true. Oh yeah, so yeah, someone else is asking, when do you figure out what track you're in? So let me point it out here actually. So so if you're here for from the very beginning for 8 semesters, it's right in here that you would pick your applied versus discrete track. So it's sort of, I think it's up to about semester 4. Up to about semester 4, you take the same you're sort of taking the same stuff for applied or discrete, but sort of right about the halfway point you have to decide. So Manasi, does that make sense? Did I answer your question? Yeah, and I think there's a person whose name is who's asking a kind of if you have, let me just say, if you have sort of more personal questions, not personal questions, but questions about your own career as opposed to more general questions. I think let's do that offline where we're not recording, and I can sort of answer your individual questions. So the person asking about portfolios and projects, let's take that. Let me take that offline, and I'll answer after we're done with all this. I hope that's okay. But yeah, that's a good question about like how to build up a portfolio. But maybe we'll get to that at the end, because I want to make sure to get to the hit the highlights in the sort of dedicated time. All right. So anyway, so what I wanted the next thing I really should talk about is like, what is it that you have to take, and sort of why does it take so long, and why can't you shorten it? Because I know that from personal experience, long experience as an advisor, one thing that people all want to do right away is they want to sort of take, can I get out quicker? Can I get out quicker? Can I get out quicker? And the answer is usually not. And in fact, a lot of the things that people do to try to get out quicker will actually lengthen their time. And that, so one of the main reasons why we have advising, such sort of advising here in math stats, is that we're trying to prevent people from doing stuff that lengthens their time, even though it seems like intuitively that it should make things go faster. All right, so here is the sequence. First, basically, you have to finish the calculus sequence, calculus 1, 2, 3, and discrete math, and it's hard to, and those are literally very literally a sequence, 1, 2, 3, right? And so you can't really, it's hard to shorten that period of time unless you take summer classes. So I actually recommend, I almost always recommend that my advisees take summer classes. Take like if you're starting from the very beginning, if you can take at least one calculus class over the summer, that will actually shorten your time to degree by a semester. And so that's actually a really good investment. So then after you, so if you sort of just come in from the very beginning, after you finish the calculus sequence, often people don't know whether maybe they want to do pure math or applied math, or even if they're doing applied or statistics, or if they're doing applied math, they're not sure whether they want to do the sort of applied track or the discrete track. And so that takes basically another 2 semesters to figure out what you like doing, what you enjoy. And then once you do that, then there's usually about 3 semesters of specialized classes to take. And this is where people sort of run into problems. If they try to take too many of them at once, that generally leads to trouble. So, and out of all these things, probably the one part that's sort of most likely that you could shorten is actually the part where you take the calculus sequence, and the other stuff is actually a really bad idea to try to shorten. So you can't accelerate. So word of advice: if you are somehow interested in graduating earlier, well, for money reasons, for example, maybe you could sort of cut a semester and then save like $4,000 or however much a semester. I guess that's how much the fees are, and then there's like more. But anyway, if you want to sort of shorten your time by semester and you're starting at the very beginning, get through the calculus, take that calculus stuff as quickly as possible, especially over the summer would be a very helpful time to do it. Anyway, so but that's your 8 semesters, like 3 semesters of the calculus sequence, 2 semesters trying to figure out what major and what track, as someone was asking about, and then 3 more semesters sort of finishing up the specialized classes in that major or track. So are there any questions about why it takes 8 semesters? Good. All right. So I think we're okay. All right. So let me just briefly talk about the calculus sequence. But there's one class which is still a little unusual, and right. So the calculus sequence you're sort of familiar with, I'm sure, and you're yeah. So the calculus the calculus sequence is sort of more familiar to many people. One thing that's very different here is that at some point in the sort of along in the calculus sequence, you probably should also take a class called discrete math, Math 42, if you haven't done that already. And and this is a really underappreciated class. So people coming from community colleges, not all of them, everyone coming from community colleges has been advised to take this class. And in fact, there are many community colleges that do not offer discrete math. That's actually something we're trying to we have a project actually running now to try to change that. But anyway, so discrete math. So one of the things about in calculus, it's sort of like you're familiar. Take the derivative of this thing, find the slope of this tangent. Draw what's the equation of this tangent line. These are things that many of you will have heard of. Not a lot of people, if you haven't taken this level of math before, are unfamiliar with the idea that this is somehow a thing you could get a grade for, figuring out how many ways there are to make a full house from a 5-card poker hand. That's like a very typical discrete math problem. So and it's very different in flavor. It's not so generally cookbooky, and it's a better indication of sort of what the rest of the major is like. Right, and so if you're just sort of starting math and you want to get an idea of what the rest of your time here is going to be like, it's really the thing to take is discrete math. Even if you go into say continuous applied math into applied math, which is solving differential equations, I think this class is the first sort of inkling, like, oh wow, when I'm going to get to the big leagues, things are going to be very different. Because this class can, especially if you get the right teacher, let me say, then this class can be very different than what you had before. It's like solving little puzzles. But actually, in terms of what people pay you money to do, like how is it that math majors can earn a living? Why would anybody pay us? Well, it's because we can solve little puzzles, and solving, like I was saying earlier, solving the right little puzzle about the linear algebra on a graph can make a multi-bazillion dollar industry. So sometimes these little puzzles or solutions of the little puzzles are pretty handy. Anyway, so this is the calculus sequence. The next step in terms of what I recommend, like that people should take, like what should you take after you finish the calculus sequence, then math past calculus is very much not cookbooky. It's instead of learning procedures, it's often more like you learn like ideas, like you learn sort of conceptual ideas. You take a conceptual approach to mathematics. You learn to be creative, and you learn to be clever. I mean, so being clever is something you can actually teach yourself, and you actually learn. And so among the many recommended proofs, among the many recommended classes that you can take sort of after finishing the calculus sequence are linear algebra. Everybody should take linear algebra. And so many of you, so this is a new thing. This is now a lower division course. And so many of you, many folks coming from community colleges will have taken this already. So it's basically the problem. It's the problem of solving many linear equations. We have several flavors of this, not just Math 34, but also Math 33A. It's ordinary differential equations. You solve equations involving derivatives, and that involves that sort of points you towards the applied side of applied math. There's statistics, Math 161A. You just that you take that after taking Calculus 2, actually. So despite the high number, it's relatively accessible to everybody. And you know, which deals with randomness and error and data collection and interpretation. And so that points you towards the direction of statistics. And then if you know you might be interested in pure math, or if you're going to be let me point out this is so teachers. So one I think underappreciated fact is that high school teachers got to learn about proofs, and the sort of upper division classes, math classes in the teaching in the Math for Teachers program, whether they be in the integrated program or not, all involve theory and proofs. Yeah, this is actually I'm actually teaching one of those sorts of courses. It's called abstract algebra, and the strange thing I've only sort of now just realized somehow is that high school mathematics, like basically all of high school algebra, is really something called ring theory, and right, it's kind of fancy abstract subject called ring theory, but it's just ring theory is really, when you study high school algebra, that's really what's going on. And so the reason why high school teachers have to take this kind of theoretical stuff and do proofs is because the stuff that y'all are going to deal with is actually pretty fancy stuff when you get right down to it. So taking these three classes, I think everybody should take. And then if you think you might be going in the theory direction, or if you're interested in secondary education, all four of them. So yeah, and if people sort of finish the calculus sequence, they come to me like, well, what should I take next? These are the things that I recommend. Learn some linear algebra, learn some differential equations, take statistics, and if you think you might be headed towards the pure direction, or you might be headed to secondary education, or if you're interested in grad school of any type, then taking a proofs class is probably a good idea. All right, so any questions about the second stage of things? So the first stage was the calculus sequence, and this is the second stage. This is kind of where you figure out what kind of math you find to be most interesting. Okay. Right. So yeah. Oh, good. I changed this. Yeah. So like I was saying, this is a good way to change to choose a flavor of math that you want to study, or to change your flavor of math. And it's also very much true that at this point, this is about halfway through the program, about four semesters, your fourth and fifth semesters. At that point, it's much easier to change your direction than it is to try to do it later. So yeah. So like I said, this is a good time to choose your direction or change it. And so let's see. I think besides general advice, I think I should maybe. So I want to talk just briefly about some of the kinds of core classes you see in our now sort of three main flavors. There's in the BA math. So that's what you might call pure math, or preparation for teaching. So the hard classes there involve proofs, and each of those classes kind of like two regular math classes, and those include linear algebra 2. So it's like linear algebra, but you prove all the theorems. There's that word. So the operative word that comes up in all these things is the word proof. Yeah, and then abstract algebra. It's sort of the algebra behind high school math, but and beyond, way beyond. And then analysis 1 is all about proving calculus. It's sort of like, why does calculus work? Well, now we're going to prove that it really works. So yeah, so that's kind of what that's a typical sort of 3 hard proof classes that people take in the BA math. So the core courses in the BS applied math and the applied and computational track, in the applied track, so typical courses that you use when you study math that's applied to problems from science, engineering, and technology. There's things, partial differential equations. Then you're solving the differential equations coming from heat, say heat, or studying waves. A numerical analysis that you solve. There's 143M where you solve linear algebra on a computer, and Math 177, linear and nonlinear optimization, which means you're solving min-max problems. Which, if you've taken calculus already, you may maybe vaguely know there's something like interesting about a min-max problem. Like, how do you make what's the shape of a box that uses the smallest amount of cardboard? Here in this class, it's actually I think there is some calculus involved, but there's a lot of stuff that's not calculus. It's really kind of surprising what's involved in optimization if you haven't seen it before. Those are the kinds of things that you take in the applied track. In the discrete math track, it's really, so this is sort of our version of a CS degree is basically what it is. It's math, but a CS degree. And so core courses include applied and industrial algebra. So I mentioned abstract algebra 2 slides back. And this is the same thing, but you make money from it. Graph theory, that's where you have both theory and also algorithms for mathematical graphs. And mathematical cryptography, this very conversation that we're having over Zoom is encrypted at both ends, so nobody can eavesdrop in on it in the middle. And so in this class, we talk about the math that's behind that. So I think maybe this gives a pretty good idea of what this is what the applied and computational track is like, and this is what the discrete math track is like. So maybe that might actually give you a pretty good idea of what you have in store for you on either of those tracks. And then finally, our fourth main flavor is statistics, which so the core courses there include probability, and that's the mathematical theory behind statistics. A regression, which is fitting curves to data well. I mean, that doesn't sound, I don't think I made that sound so interesting. So let me tell you something I read on the internet, a little joke I read on the internet. Let's see, how does this go? When you're trying to get it funded, you call it artificial intelligence. When you're hiring people to do it, it's called machine learning. And when you're doing it, it's regression. So this is, so if I call this by its other names, this is artificial intelligence or machine learning. It's curve fitting, basically, is what it is. And so this is a really important thing. It's both a really important class in this major, but it's also really important to main life, to everyday life now. Like so much of modern technology and the modern industry is artificial intelligence, or in other words, it's curve fitting, is what it is. Anyway, so it's fancier versions of trying to sketch a straight line through through a scatter plot. Who knew that would be so useful, huh? And then also as actually in so many of our main majors, but in statistics, they're very good about having you do some sort of real life statistical programming. SAS and SA. Oh, right. This is out of date now. So this used to be called. Shoot, I forgot to change this. What you really want to take now is 167R, which is R programming. It's the same. I think it's essentially the same class, but you're using a different language called R, and because R is sort of a more modern way of using programming that handles big data questions. So this should really be 167R, which is R programming. Anyway, yeah. So if you sort of follow the news at all, even on the internet, about what sort of modern big data stuff is like, you can sort of maybe start to see like, well, oh yeah, statistics, that's where the money is, right? You can sort of see why this is the thing that we sort of get people interested in business to major in. Okay. Oh yeah. And so we're going to finish up with some general advice. So are there any questions about sort of what those four big life paths are like? BA math, applied math, applied track, applied math, discrete track, and applied math, statistics. So are there any questions about those four tracks? Yeah, pure math, applied, discrete, and statistics. So good. Okay, so let's see. Yeah, we're getting. Let me be efficient here. So I want to. So here. Oh, can you double major in two applied? There's not really a point in doing that. I don't think you can, because one, I don't think you can because there's too much overlap, and two, I don't think there'd be any point in it. I mean, I think beyond a certain point, people are less reliant on sort of exactly which subject matter um, uh, you take, and sort of more interested in sort of what certain habits of mind and sort of skills, mental skills that you have, and so even if you could double major in the two applied, I don't think it would make that much difference. Probably what you would, if you're really interested in doing both, in sort of doing both applied discrete or an applied applied. What I'd recommend you do is just choose one of them, whichever one you like a little bit better, and then take some of the courses from the other one. And then what happens when you apply for jobs, you can write in your resume. You can write in your resume something like, well, my degree is in sort of regular applied math, but I also took graph theory and combinatorics and cryptography. And so yeah, so I think you just the thing to do there would be just to list what other courses you took in your you took. And I think people end up doing that anyway, because yeah, that's a sort of fairly standard thing to include in a resume. Is just what particular bits of specialized knowledge you happen to have. Another question is, how about double majors in applied math and CS? Yes, yeah, you have to work it out so there's not too much overlap. There are these overlap rules that I've never quite understood, but you have to sort of work it out so that there is yeah, you have to work. So if you have a double major, they can't have too many courses in common, so you have to sort of work that out. But yes, there's certainly plenty of people who double major in applied math and CS. How easy is it to take classes that are not in your track? You are actually required to take classes that are not in your track. So if you go down the discrete track, you're actually usually required to take something in the applied track. And if you go down the applied track, there's actually one slot in the applied track that's dedicated for something from the discrete track. So yes, it's not only is it easy to take classes not in your track, it's actually required. Here's a hard problem. Hard question. If I follow the roadmap, will it naturally space out the math and GE classes? It depends on which major it is and which roadmap. I think my answer would be not always. I mean, we tried our best, but the sort of constraints we have on so if you try the roadmap, and so here's what I actually advise people to do. If you follow the roadmap, but you speed it up by one semester by taking by very early on taking a calculus class over the summer, which you can actually do at your local community college. Because one thing that you'll rapidly learn is that there are not any useful summer classes for math stats majors basically after the fourth semester. So there's not a whole lot of stuff you can take. If you at the end you're like, oh, I want to go a little faster, can I take things in the summer? Well, it's sort of too late then. But especially if you go at the beginning, if the beginning of your career here, and if you're coming in sort of starting from the beginning, starting from calculus, if you follow the roadmap but speed it up a little bit by taking, say, Calc 3 over the summer of your first year, that will space things out really nicely. If you follow the roadmap, I'm pretty sure did I mention this one slide? Don't take more than 3 math stats classes each semester. And somebody actually quite wisely said, well, it's probably better to take 2, maybe like 2 math and 1 CS, something like that. So I think the roadmap actually recommends taking 3 a couple times. And but if you plan ahead, you can actually avoid doing that. Maybe I think if you plan ahead, you can maybe do that just once. So if you follow the roadmap, it's as long it will sort of the GE classes are definitely spaced out, and the math classes are at least sort of spaced out. But you can actually really improve that spacing by getting your calculus done a little faster. So did I answer your question about the roadmap? Mindy, did I answer? Oh yeah, okay. All right, so yeah, I think the roadmap pretty much spaces them out pretty well, but you can actually improve that spacing quite a bit by just taking sort of one extra class early on. Or if I can't remember if you're coming from community college. If you're coming from community college, well then the roadmap will more or less space them out okay, because we were very sure not to tell anybody to take more than three math classes a semester, but but it's maybe not quite as comfortable. All right, so and you can sort of see the second piece of advice which is to space out your GE classes. Something that I hear all the time, which I really don't understand, is to get all your GEs done first, and which I've always thought is a terrible idea. I don't know who keeps saying this, but I guess if you don't know what you're going to major in, I guess, well, there's not a lot of other options. But if you take all your GE classes first, especially those last four, I think what they call now the SJSU studies classes. If you get all that done all of a sudden quickly, then there's nothing left to take but math classes. And then which means if you're going to follow this next piece of advice, which is still true even if you don't have any GE classes left to take, then you're stuck. Either you take 4 math classes a semester, which is bad, did I mention, or you have a semester where you're not taking more than 3 classes. And so you should just those will take care. So especially the upper division GEs, the SJSU studies classes, I tell everybody that those just kind of take care of themselves. Okay, there is an exception out here, but for the most part, those really just take care of themselves. But the one exception is if you should take the writing skills test, the WST, as soon as possible. As soon as you get that done, get it done, because that one actually, if you pass it, great, and then you're all set, and it's done and out of the way. If you have trouble passing it, especially for example, if English is not your native language, then it sets up a multi-step process. What is the WST? So there is somebody that's also putting out a good piece of advice here with this. So it's the writing skills. So let's see, how does this go? So everybody has to take 100 W. This is the WST is the writing skills test. Or it's not called the WPT. Did they change the name? I totally missed that. Anyway, so there used to be this test that you have to take. So the final goal is to take 100 W within your major. So the idea is that that you should learn how to write well in the context of your own major. And so we had some trouble staffing that. And so what happens for us is that we end up having students take engineering 100 W, which sort of both fulfills this writing requirement and also fulfills another sort of SJSU studies class. But anyway, so that's the goal, is to get the 100 W. But the point is, if writing doesn't come naturally to you, or if you have trouble passing the WST or passing 100 W, this can actually become a sort of multi-step process that takes a long time. It takes several semesters. And so the one time when you can really run into, if you wait until the last minute to take the writing skills test, so and somebody's making then right. So sorry, but so let me finish what happens in non-quarantine times, and then thank you very much for making this point on the chat. In the quarantine, you don't need to do it. So in non-quarantine times, in sort of typical time, in normal times, if anybody remembers what normal times were like, you have to take the WST, which that gets you into you pass it and get into 100 W, or you don't pass it and then you have to take a sort of secondary class until you pass that, and that could take a while, especially if writing is not your thing. And so right, and so somebody on the chat here is making the very good point that right now you don't have to take. So thank you for making that point. So let me add here, but right now this is not necessary. I should say in quarantine, WST is no longer necessary. So if you feel up for it, you can just, if you feel ready to go and take 100 W and sort of finish up your writing requirement, you can just go for it. And because the whole testing mechanism was totally based on loads of people being in the same room at the same time, which is obviously not going to fly right now. So thank you for pointing that out about whoever this is in the chat, pointing that out about the reminding me about that you can skip the WST. In normal times, let's see, can you take it more than once? I believe you can take it more than once if you fail the first time. But if you fail at one, so I think the usual thing that happens, if you don't pass the WST to get into 100W, but you feel you're close, then you just take it again, and it'll usually work out. But if you're sort of far off, if you're far out, and if you think you're not close to passing, then you have to take English LLD 100A. But oh, and if anybody's coming in here from the very beginning, if you're taking like English 1A right now, then you're a ways off from thinking about this. So, and the folks in those classes will tell you if and when you have to take the WST. So did I answer everybody's question about the writing? Okay. I think what kind of, I don't actually know what's in the WST. I think they just like give you a prompt. It's like an essay. It's an essay test. So they give you a prompt. You know, so write about I don't know, economic inequality, and you know, respond to this following paragraph, and you just write an essay. Yeah. Yes, you just write an essay. Yeah. So but right now you don't have to do this at all. You just, if you feel ready for 100W, you just go for it. Once you've taken the sort of class prerequisites, which I think is like English 1A, and then either English 2 or 1B. As despite being an advisor for many years, I always just sort of outsource the GE advising. I just say go talk to the and just Google it, as somebody points out here. Go to the WST website somewhere, and then it'll give you sample essays and sort of give you an idea what that's like. But as we've said several times right now, until quarantine is over, you don't have to take it. So so that's something to worry about later. Okay. Oh, now I'm really glad I led with this slide, because I wouldn't want to get here just like with 2 minutes before the ending and say like, do not take more than 2 or 3 math classes a semester. I'm pretty sure the roadmap doesn't tell you that. It tells you not to take more than 2 or 3 math classes a semester, but it doesn't say like this is like the upper limit. And so sometimes people be tempted to sort of sneak another one in. That's a bad idea. And so this for sure is by the surest way to slow down your graduation is to take 4 math classes in a semester. Almost without fail, this will slow people. This will delay people's graduation by a semester. It's totally counterintuitive. But that's the way it works, because it's just too much, and people don't pass one. And every time you don't pass a math class, it gets much harder to finish it. Like you're like way worse off by taking a class and failing it than you would by not taking it at all, because for any number of reasons. So don't take more than 2 or 3 math classes each semester. Okay, so another piece of, the last three bits. So allow lots of time for upper division courses. This is maybe a little controversial. Okay, well, these last 2 are jokes, but try to cut down on unnecessary time. And one thing I really sort of I do advise, though, this is really kind of the debatable point. I think not everybody agrees with this. That if you don't need your job, I think right now a lot of people need your jobs. I mean, like if you're working now during quarantine, you probably really need that job. But if you're in a job that you don't need and you're starting to run out of time, cut down your hours and or at least try to get some sort of job like tutoring, which has obvious professional value as opposed to like making lattes. And I think really, so try to make sure you allow lots of time for upper division classes, and really the biggest time eater, and therefore the biggest potential source of time, extra time if you need it, would be to sort of cut down your hours at work. And so if you can do that, that's actually a really good investment. It's better to spend that time in your schoolwork, and that will actually end up saving you money in the end. And I'm kidding about seeing your friends, though I guess seeing your friends isn't really an option right now. Oh, well. All right. So quickly. So here, just these last 2 slides about how to survive, and then this is maybe more true than ever in quarantine. So find community and get support. So you don't have to go it alone. Get to know other majors and profs. Talk to other people in your classes and form study groups. I think that if you're lucky, that can still be possible. I think a lot of classes now use discussion forums, use Piazza or the Canvas discussion groups. And so get on those discussion groups and say, hey, I want to form a study group. Let's get together and like meet on Zoom at some particular time. And that, you know, I highly recommend it. That seems to help a lot, help people a lot in finishing. We have, we have this wonderful thing called the Math Stats Colloquium, and you'll hear much more about that in the coming weeks. Go to your professor's office, especially now. Go to your professor's office hours. Make sure the prof knows your name, and actually, right these days, make sure the prof knows what you look like. Turn on your camera and say hi, because it's somehow much easier to relate to a person if you've seen their face. And someday, well, we can all get together. Who knows when this will happen? We hope to have a majors only common area where you can socialize and talk about random stuff and get help with classes. So that was just sort of starting up when we went into quarantine, and I hope we'll be back there soon. All right. Anyway, so if you need support, talk to your fellow majors. Go to your professor's office hours. I mentioned, bug us. That's our job. And talk to your advisor. And so you can ask us questions anytime. And we may take a while to answer. Okay, if you ask me, it may seem like your email went into a black hole for a while, but I will eventually answer you. And so you're welcome. Welcome to San Jose State. Enjoy your time here. And I think we are over time by 2 minutes. And so what I'm going to do, I think I'm going to let everybody go. And I'll pause the recording for like 30 seconds if you want to take off. And then, if you have more questions, I will answer those questions and just put them on the chat. And anyway, thank you very much for stopping by. And it's been a pleasure to speak with you. And those of you on YouTube, the recording will continue in a minute after a brief pause. Okay, and we're back. One question, another question in the chat. So is there another lecture of this for grad school preparation? Yes, 1 week from today. Yes, 1 week from today, we're going to be talking about how to prepare yourself to go to grad school. Completely different material. And so you'll get an email about that soon. It'll be me again. That's the only thing that'll have in common. But yes, it'll be completely new material next week. It will also be saved onto YouTube if you can't make it. Question: How do I know who is my advisor? We're actually still working that out. As much as possible, it's not always possible, but as much as possible, we like to try to give you the same advisor for your entire time at San Jose State. We will send you an email in probably in mid-September or October. Probably mid-September, I hope. Okay, any other questions? All right, well, if you have any further questions, will an Open University student get an advisor? It depends on why you're on Open University. Let's see. So if you've never been a San Jose State student, you probably will not get an advisor. But you could just email me, and probably I'll be honest, if you bother me enough, not too often, but maybe like once a week, I will eventually give you some help. Let's see. The one time when an Open University student would definitely get an advisor is that sometimes Open University students who are coming back, who were away from San Jose State for a while for whatever reason and coming back, those folks can usually probably get an advisor. So somebody asked, when will my major change from BA Math to BA Applied and Computational? Eventually. So one thing, as you may have learned about San Jose State, is it takes forever for paperwork to grind its way through the system. So and having everything go online and having the pandemic and quarantine does not help the speed of the paperwork. But I'm afraid I don't have a better answer than eventually. Maybe ask your advisor if you're worried about whoever you filed your change of major from BA Math to BA Applied and Computational Math. Whoever you sent that form to, maybe just gently ask that person what's the status on that, maybe every week or two, and eventually you'll get it. And not soon necessarily, but eventually you get an answer. The math club. So somebody asked, well, what happened to the math club? Are you asking about the physical room, or are you asking about the organization? The organization. Well, it's sort of defunct right now. We haven't been running it for a while. What we're actually trying to do is we're eventually. So see this thing here that says as T goes to infinity in the long run, we hope to have a math stats majors only common area, and we were just kind of working out the kinks in that when we hit quarantine. What we'll probably do, our long-term goal is probably we're going to replace the math club with essentially a room that only math majors can get into. I mean, we can't really enforce that, but that'll be the idea. I guess it'll be a room where that sort of only math stats majors have guaranteed access to. So and I had to say, as we were just before quarantine, I noticed that you remember there's that room on the 4th floor of Macquarie Hall where people used to hang out. If you were here, yes. So that not an official math club, but that was de facto a math club. And so that's the long-term solution here, I think, is yes, for Pi Day is celebrated by pizza. So eventually there's just going to be a room where math stats majors hang out. And that will be as good as probably as effective as a math club, as any kind of official math club, if that makes sense. I don't know. Yeah, I mean, there are actually sort of, there's an official, I forget the name, but there are actually, I think it's called Pi Mu Epsilon. But there are actually a sort of official college math organizations, and so if you're really interested in that, you could try starting a chapter of one of those things, and that'd sort of be even better than the math club, because it would really only be limited to math majors or math stats majors. But yes, we will have some sort of eventually we will sort of be able to restart some kind of social organization for majors. So any other questions? Okay, everybody. Thank you so much for stopping by. YouTube, thank you very much for listening. Thank you for your time. And welcome to San Jose State, and take care. Stay safe and stay well, and and God bless us all. I'm just super tired. All right, bye.